In this lesson, you will learn how to solve triangles using proportions. In addition to the congruency similarity criteria that you learned in Lesson 1, you're also going to use the triangle proportionality theorem to solve triangles. The triangle proportionality theorem says that if a line parallel to the side of a triangle intersects the other two sides, then it divides those sides proportionally. So here we have a triangle. BC is parallel to DE, and that DE line intersects the sides of the triangle. So that means that this intersection and this side of the triangle that are parallel are proportional to one another. So let's use that in solving triangles. Example number 1, we're going to find PN. So let's let PN represent or be represented by X. We can set up our proportional ratio using the triangle proportionality theorem. So LP is proportional to PN, and MQ to QN. Always be consistent with the parts of the triangle. So if you start here on the left side of the triangle, top to bottom, you then need to do the same thing on the right side of the triangle, top to bottom. So substitute in your values to solve. So we have 3 over x equals 2 over 5. You can cross multiply to solve. So 3 times 5 is 15. 2 times x is 2x. Divide by 2. We find that x equals 15 divided by 2 is 7.5. So that means the length of PN is 7.5. For our next one, number 2, we're going to find the length of RN. So RN we're going to be represented by x. Notice here we also need to find MQ. We know the whole length of the side of the triangle is 13. This portion Q to P is 5, so the remainder would be left here for MQ. So just take 13 and subtract 5 to find 8 for that length of MQ. So set up your ratio. I most times like to start with my unknown. So RN is what we're trying to find to the MR. Because I started on the right hand side and then went to the left of that side of the triangle, we'll need to do the same with the other side of the triangle. Start to the farthest right hand side. So QP to MQ. Always stay consistent with your ratios when setting up those proportional equations. So plug in your values. So RN is what we're trying to find over MR. QP is 5 and MQ, which is 8. You can cross multiply to solve. So 8x equals 50. When you divide by 8, we find that x equals 50 divided by 8 is 6.25. So that means our length of RN is 6.25. Let's look at example 3. We're asked to find the length of CB. So that's what we're going to let x represent. Notice that these triangles are two separate figures, so we cannot use the triangle proportionality theorem, but we can still set up a proportion because we know these are similar triangles by angle, similarity. We have angle A that's congruent to angle D, and we have angle B that's congruent to angle E. So these are similar triangles by angle, similarity. So that means that the sides are proportional if these are similar triangles. So start with your unknown. CB is our unknown side, and we're going to set that up with FE, the corresponding side in the other triangle. Then we're coming back to this first triangle. We have AB, and that corresponds to the side DE. So substitute in your values. So we have x over 10.2 is equal to 7.5 over 15. Cross multiply to solve, we get 15x equals, we'll have 10.2 times 7.5, which is 76.5. Divide both sides by 15. And we find a length of 5.1. So our length of CB is 5.1. Similar triangles have congruent angles and proportional sides, so we can set up this proportion and we're able to solve for CB. Let's look at number 4. We're going to find the length of DE. So DE is here, that's our unknown side. We know that we have congruent angles here at angle C because they are vertical angles. So BCA is congruent to DCE, so that's a pair of angles. We would also need to see if our sides are proportional. So 3.5 is the short side. I'm going to compare that with the 5.6. So 1.6 is that ratio. Let's also compare it with the other pair of sides that were given. So 6.4 with the 4.0. So we are seeing that those are proportional. So we can set up a ratio of the unknown side, DE, with BA and solve that proportional equation. So DE goes with BA. And then just choose another pair of the sides, whichever numbers you want to work with. You can work with the 3.5 and the 5.6, or if you prefer the 4.1 and the 6.4. But know that since we started with the DE triangle, this triangle on the right, we need to continue to do so. So we're going to use CE from that triangle on the right and compare that with AC. So plug in those values. We have x over 5.2 is equal to 6.4 over 4.0. Always being careful to make sure your proportions are matching up from one triangle to the next. Each sides that correspond together within your ratios, and that the triangles also, if you started here on this triangle, you come back to that triangle for the next ratio. So let's cross multiply to solve. So we get 4x equals, we'll multiply 5.2 times 6.4. We get 33.28. Divide both sides by 4 to find our length 8.32. So the length of DE is 8.32. You could always check these solutions by plugging them back into what you originally set up to make sure that they are still proportional to the other parts of the triangle.